So guys, I'm John, URK18CS074. Today I'll be talking about experiment 8 in Python programming lab, which is handling threads and dealing with multi-threading and producer-consumer problems. So let's go to the first question, which is implement multi-threading in which three threads concurrently calculates square, cube, and factorial of a given number. Let's go to the code. So we observe this code. What I did was I just imported threading and I just import a time module to calculate the entire time that this process takes. I just compared it with the regular execution, and this execution takes more time because it's creating threads and deleting the threads at the end of the time. So it will be more than the normal execution. So let's talk about the methods I use. For this method, it's just going to return square, print the square. This method is going to print the cube, and this method is going to print the factorial of the given number. And I created three threads. And I start and I started them, and I gave the join. I call the join function of this thread, so they are going to run concurrently. Let's start this. As you can see here, I passed 3 as an argument to this method. So the square of 3 is 9, and the cube of 3 is 27, and the yeah, factorial of 3 is 6. So and the time it took to finish is almost 0 seconds. So coming to the next question, implement a thread synchronization using producer consumer problem. So before I talk about this, I want to talk about this. So as you can see here, this is a code which I wrote myself to understand how thread synchronization works. So as you can see here, yeah. So in order to achieve thread synchronization, we are going to use a predefined conditions in threading. So what I'm going to do right now, what I wish to do right now is a kid will be waiting at a bus stop. He'll be at the bus stop number 6. So he's going to say when the bus reaches him, he's going to say, "Whoa, bus came on time for school." So this is easy to achieve in one definition, but that's when the thread should be synchronized when they are in two different definitions, two different methods. So this method talks about the bus. So this method prints where the bus is every time. So for every 2 seconds, it's going to move from one stop to another. That's the reason why I put this time dot sleep. So once it reaches the sixth stop, which is x is equal to 6, which is x is equal to 5 because it's 1 to 6. So it's so the fifth stop is the sixth stop. So driver is going to say, "Hello kid, I'm here, get in," and that is when this thing should come. Whoa, bus came, time for school. So I achieved this using synchronization, and I'll show you how. So right now, if you run this program, it's going to they are running asynchronously. So what happens is I'm waiting for the bus stop at 6. So it's going to print this. So since it slept, this thread is currently asleep. Since it's a since you are using multi-threading, it goes to the second thread, which activates the bus method, and the bus one prints. And since 2 seconds are done, it's going back to the thread one and prints where bus came. So this is asynchronous. So how are we going to achieve synchronous is by using conditions, by using logs, and by using wait and notify. So what I want to do is declare a condition, just dot condition. Yes. So using this object that I created from threading.condition class, I'm going to give this. I'm going to make this script recognize this particular blocks as the main task. So what I'm going to do right now is cd.acquire, and when you end this, when this main process is ended, you release the lock. So I don't want this statement to be executed before. So what I do is cd.wait. So same thing with this. You this whole bunch is a task, and you need to make sure that your computer knows this. So that's the reason why we do this acquire and locking, acquire and release. So what I want to do right now is when do I want to wait notify this wait so it can actually move to the statement is when this condition is satisfied. So the driver says hello, I am there, and then kid sees the driver and he notifies the kid. So this is when you click notify, it's going to notify wherever there is a waiting situation, which is here right here. So that's the time when he says the bus is here. So now you can see. So the kid says I'm waiting for school bus at stop 6. So bus just goes to the next stop every 2 seconds. So once he reaches the sixth stop, driver says hello kid, I'm here, get in. So bus came time for school. So this is how we achieve synchronization in multi-threading. So the same thing with consumer and producer problem. So what happens here is uh, so there is a common buffer which is Q for right now. So this common buffer is going to get assigned with all these values in this particular list. So same thing I initialize then condition. So what happens right now is I created a class. So in that class is definition run, and so what I'm doing right now is I'm taking each and every value from this list and I'm going to append it to the queue list. So whenever there's an element in the queue list, the consumer is going to consume it. So whenever the producer haven't produced uh, number, any number from this list into this list, the consumer need to wait. So the consumer need to wait till the producer notifies. See, there's a notify command in producer. Till the producer notifies the wait command, which is here for the consumer. So I'll just tell it easily. So as I told you, this is the chunk of task, and this is where I need to notify them. This is the main bundle of tasks you need to see. So appending and everything is common. So this notify is not going to be activated before because the first thing is it's linear interpreter, so it's going to go to the producer. So it's not going to, even though it gets executed, it's definitely not going to be used. So once the consumer class is called, which is right here, the consumer thread. So once the consumer thread is called, it's going to go. This is the index of the list, basically nothing more. So condition.acquire, this is the chunk of code, condition.acquire to condition.release. So if not queue, so if the queue is empty, it's going to say nothing in queue, consumer is waiting. So this is a basic code consume. So instead of just moving away, we are just waiting. So once this wait command is used, it's going to go to the next thread. And once the 5 second sleep time is done, then the producer starts producing again. Once it's produced, it's going to notify. So what is going to notify? The wait command, so which is here. And once this activates, once this pushes off, then it says producer added something and notified the consumer. So now it's going to pop that number in the buffer list and increase the index value. So it says consumed and what number it's consumed. Let's run this. That's basically how that worked, the student and bus thing. So here the both kid and the school bus is moving. That's how you can see. So whenever they meet together, that's when this synchronization occurs. Producer one should consume one, nothing in queue. So nothing is produced in the queue right now. So consumer should wait and produce two. Then producer added something and notified the consumer. So then it starts consuming. So then consumer should wait again since producer did not produce anything. So obviously there is going to be a delay in producing because I gave more sleep time to the producer. So as you can see the difference more while whereas consumer thread is going to sleep only for 2 seconds, but producer thread is going to sleep for 5 seconds. So seeing that, let's go to the third question. Write a Python program using multi-threading through which we print the thread name and corresponding process for each task. So yeah, this is the code for it. So what I did was I created three different methods, which one waits for 3 seconds, another wait for 4 seconds, another wait for 5 seconds. So it says I'm waiting for, and it shows the number of seconds in this loop. So there's a predefined function where you can get the name of the thread, which is thread.getName. So it's going to print the name of the thread which was asked in the question. using multi-threading, through which we print the thread name and the corresponding function. So I'm going to print the corresponding function inside the method. So what I'm going to do right now is, once the thread is ended, I'm going to print the name of the thread which is ended. So same thing everywhere. So the current thread name, and I'm going to print the process which is executes in this. So this thread processes, it waits for 3 seconds. So this process, it waits for 4 seconds. And this process, it waits for 5 seconds. So it's basic. So now you can see here the current thread name is 3-second thread, which is the first one. Where you assign the names here. Yeah, 3-second thread. So it waits for 3 seconds, 3, 2, 1, and next it goes to the next thread, which is 4 seconds. It waits for 4 seconds. Next it goes to the next thread, which waits for 5 seconds. So 5, 4, 3, 2, 1. So at the ending, it says then it prints all the names of the threads that were executed and says they are ended. So this is for the 8th experiment. Thank you guys. I'm URK18CS074.